Hello friends, my name is Ankit Balvanshi and I welcome you all on the video lecture on the topic Unit Hydrographs. So, what is a unit hydrograph? The amount of runoff resulting from one unit of rainfall excess is unit hydrograph. One unit of rainfall excess, it can be 1 centimeter, 1 mm, 1 feet, etc. It is essentially a tool for determining the direct runoff response to a rainfall. Once you know the watershed response to one storm, you can predict what its response for another one will look like. So, here is a typical representation of direct runoff and a base flow, and this whole is known as unit hydrograph. So, here we can see on the y-axis we have Q, that is the discharge, and on the x-axis we have the time measured in intervals of hourly durations. So, there are various assumptions of unit hydrograph. Number one, the effective rainfall is uniformly distributed within its duration. Second, the effective rainfall is uniformly distributed over the whole drainage basin. Third, the base duration of direct runoff hydrograph due to an effective rainfall of unit duration is constant. The ordinates of direct runoff hydrograph are directly proportional to the total amount of direct runoff of each hydrograph. Last, for a given basin, the runoff hydrograph due to a given period of rainfall reflects all the combined physical characteristics of basin, that is, time invariant. So, hydrograph analysis, recession and base flow separation. So, these are the techniques which is used for the hydrograph analysis. In this, the hydrograph is divided into two parts. First one, direct runoff, and second one, base flow. Direct runoff ordinates include some interflow, whereas base flow is considered to be mostly from contributing groundwater. Recession curve method is used to separate direct runoff from base flow and by an exponential depletion equation. Now, there are various methods to separate the base flow from the total runoff. First one is the straight line method, second one is the constant slope method, and the third one is the fixed base method. In the straight line method, assume base flow is constant regardless of stream height or discharge. Draw a horizontal line segment AD from beginning of runoff to intersection with recession curve. So we can see that AD is the straight line joining, and above line AD is the direct runoff and below line AD is the base flow. Second method is the constant slope method. In this, connect the inflection point on receding limb of storm hydrograph to beginning of storm hydrograph. It assumes that flow from aquifers began prior to start of current storm, arbitrarily sets it to inflection point. In this case, draw a line connecting the point AC, connecting a point n times period after the peak. So we can see the inflection point and point A to C. So the area above A and C is the direct runoff, and the area below AC is base flow. Last one is the fixed base method. Assume base flow decreases while stream flow increases, that is, to peak of storm hydrograph. Draw line segment AB from base flow recession to a point directly below the hydrograph peak. Then draw line segment BC connecting to a point n time periods after the peak, where n is equal to time in days, where DRO is terminated, A is equal to discharge area in kilometer square, B is the coefficient. Thank you, stay tuned and keep learning.